Hi, it's mystery mailbag teardown time by popular request on the Twitterverse. I put up a poll and everyone wanted this instead of a new thing Keysight sent in. So here it is, mystery teardown. Hi to all my Norwegian viewers, and thank you very much Morten Lykvold for sending this one in all the way from Norway. Hung at the right angle. It's a bit of a mess. It's almost Kamigatsu in the postal system, but yeah, like I did not cut that, so yeah. All right, I think I'm going to put this on the floor. And apparently it is defective, so we don't have to tear it apart gently. It's got no handles, it's all smooth. Jeez, it's all smooth. Oh, Bobby Dazzler. Oh, it's a Syvix. Syvix? A cervix projector. We're going to project onto a cervix, are we? Well, there it is. It's a Syvix brand. Never heard of it, but apparently it's a panoramic projector. Powered optics and lens shift. Ooh, fancy. But look at the, I mean, it's all the way back. Look, something comes out. Here you go. Oh, it's got a screen on it. Oh, wow. Oh, this is a, wow, look, fancy pantsy. Oh, my goodness. Yeah, and what's an export? I don't know, but look, it's got dual link DVIs. It's got 2 VGAs, got the RGBs, and we've got an RS-232. We've got 3D sync. So it's a 3D panoramic projector and 2 HDMI inputs. It's got the Ethernets, so maybe you can stream to it. I don't know, but it's got a screen and everything. Like, and this is serious. Look, we can iris, shutter. This is a serious bit of kit. We can choose all our different inputs, and then we can change the iris and the shutter and the zoom and the focus and the whatnots on it. That's very impressive. Wow. Yeah, I've never seen that sort of array of ports on a projector before. I don't know if you ever used it. Leave it in the comments down below. Got a bit of foam stuck in there. Apparently it is defective, so I don't know, I might be able to power it up. We might get something on the screen, maybe. Hazardous moving parts, warning Will Robinson. Yeah, and the foam has gone all the way in there, and I see a big centrifugal fan in there, so, yeah, it could come guts if I turn it on. But look at this. Still got the factory protection film on it. 4K film porn. Whoa. And it's made in Norway. Wow. I don't think we've ever torn down anything made in Norway, have we? Leave it in the comments. And on the other side here, it's just got 2 lamps inside. So, I don't know, should we power it up and just see if any lights come on? Yeah, why not? Going to violate my own rule. Just going to plug in the mains here and see what happens. Switch her on. Oh yeah, got something on the screen. Yep, starting up. But I've been told it is defective. So, come on. Oh, jeez. Twiddle your thumbs. Oh, I think I'll play some Galaga while I'm waiting. The fan just started up after the boot up. And there's our foam. It's come back out. And it's, yeah, look at that. Kind of boots up. Color temperature, 65,000 Kelvin. Gamma. Wow, you can adjust it all. But yeah, I'm told the projector doesn't work. So it's been run for 2,300 hours, remaining life, 0 left in that lamp, and 983 hours remaining in the second lamp. Shutters, unknown shutter, no lens mounted. 11,000 hours this sucker's been used for. So yeah, it's had some use. Yeah, and the lens was missing from the front. That seemed obvious. Well, that clinches it. Teardown time. So yeah, you can see the size of I can put my whole hand in there, right? There's a lot missing in this sucker, and yeah, that comes out. So it looks like there's like a big lens assembly that goes in the front. So that's obviously missing. There's the full blurb. It's the F35 WQ XGA resolution VS Bright Infotech Right EXPXT in black metallic color, I guess. Yeah. Anyway, it's an 800 watt jobby, so made in Norway. Beautiful. Looks like the top cover here is going to lift off if we get all these screws around the outside off. metal threaded inserts. Thank you very much. Has anyone got any clue what this thing cost? Yeah, some sort of massive. I'll put up an image as what it's supposed to look like. Some sort of massive, wide projection, panoramic video, like a PC projection thing. So this is not something that you'd be watching your Top Gun Mavericks on. This is more for really projecting a computer screen to a very large audience on a massive screen. Although it's pretty dated these days, but I'm sure it was the duck's guts back in the day. Lamp still in there. Look at that. And that is RFI shielded as well. That'll be conductive. I bet your bottom dollar. Pretty schmick. And there you go. There's our lamp assembly. Wow, look at that. That's a Bobby Dazzler. That'd cost a small fortune. But that lamp assembly is just an impressive bit of kit. Unbelievable. So, what is it, like a halogen lamp kind of thing? So they've got like an intelligent board on here, which, has got like ID. It's probably got, service life and stuff like that. Maybe an E-square prom on there or something like that. That tells it the ID and when it was installed, how many hours it's been operating. And maybe, I don't know, there's a temp sensor in there somewhere probably. Oh, it's made in China though. Assembled in Norway though. But yeah, isn't that an impressive bit of kit? What would the replacement cost you? And inside there is super impressive as well. Look at that's actually a filter lens in there. There we go. And we are in like Flynn. Check it out. Wow, that's got a lot of stuff in it. That is damn impressive. I see an Altera Cyclone in the back, but wow. And the massive die-cast alloy heatsink for the projector, the RFI sponge there going up to the top. So the Sirius with the RFI. Well, there's the DLP projector heatsink, actually. So I'm not sure what the huge die-cast body is doing. That's dissipating heat as well, I guess, but geez, it looks like an engine block. It's just serious bit of kit. Oh, I love the Samtec board-to-board interconnect. There you go, for your interconnect aficionados. Look at that. Bobby Dazzler. Well, this thing's got so many fans in it, and 2 on this side, 2 on the other side, and it's got limit switches and all sorts of safety interconnects that it's got basically a dedicated board here that actually connects everything, like all the mechanical type stuff. I think that there's a motor down there, but that one seems to be going up to a connector board on the top here, which goes over to the DLP assembly by the looks of it. We've got limit switches up here, which engage when the lamp doors go in, so it'll automatically cut them out, like as a safety in-lock, so, people don't blind themselves, or they don't, it'd be super hot, and it'd stay hot, and they've got warning stickers all over it and everything. There's the money shot for that one, for those playing along at home. And wow, check out all the nickel screening, conductive nickel screening around here as well, right around the front panel. This just is going to lift out, yeah. This whole panel assembly is going to lift out. That is beautiful design. And we can just get access in there to the DLP projector and everything else. Terrific stuff. And there are 2 of these power supplies. You saw one on the other side there. And yeah, these looks great. Nippon Chemicon, thank you very much. It looks like, so we'd have 2 of these. No coincidence that we've got 2 lamps. So I presume they're just for powering the lamps. So that's going to be our DLP chip in there. DLP is digital light processing, basically using micro mirrors to actually reflect the light out the front of the lens. And yeah, for those, look at that Samtec connector. Oh, check out that Samtec connector. Oh, you can charge subscription on OnlyFans for that. So fan wise, as I said, they got these 2 here They got two on the other side as well. So these are angled. This is a Sunon Maglev jobby. Another Sunon over here. So these aren't one hung low brands here, which of course blows across these heatsink fins here. These ones don't get much love, top and bottom. But anyway, that blows across. But then they've got this huge die-cast alloy. It looks like a big donk. Look at it. Unbelievable. You get that on a bloody Victor lawnmower. And then it's got infrared receivers here, and there's one on front as well, I believe. So in corners, so it doesn't matter where you are in the room. Oh, sorry, I thought I was shooting in 4K, but the camera was set to 1080p. So everything up until now has been 1080p upscale, but now it's like we're on to 4K. Okay, it's all happening. Here you go. So here's the main processing board, VXP. By Sigma, no idea. It's a custom, application-specific processor for this sort of business. Got a couple of analog devices, drivers over here. That'd be for your LCD, which is over this side here. And someone has thoughtfully provided. We got a 4 gig micro SD card. I would presume that's got like the firmware on it, and then it looks like you can upgrade the firmware over here. So I'm sure that's what that's for. Altera Cyclone 3 jobby over here. We got a Freescale processor over here. That's another Altera jobby with a tiny heatsink on it by the looks of it. But anyway, there you go. That is a serious board in its own right. Oh, keep that. Might be something useful on it. Yeah, nah. There's the DLP board again in 4K, but I'll do that once again we get it off. There's our power supply again in 4K, and the Sunon Maglev jobby up there. And there's that main interface board for all the fans and all the whatnots and controlling all sorts of miscellaneous stuff that the main processor couldn't care about. Toasty. Check it out. That was the plate under that main interface board there. Ooh, Ernie Bernie. Oh, check it out. This is in front of the lamp, and you can see the color wheels here. Isn't that, it's a thing of beauty. A joy forever. Look at that. So yeah, both lamps have their own dedicated colour wheel, and here's the PCB that we went on top of that. We've actually got a date code on there. Date code 2004. Oh, isn't it pretty? Look at that. Beautiful. So, it's got a, can you see it? Yeah, you can see it on the screen. It's got like a curved thing on there. Why does it have sort of like a curved bit going in there like that? Wonder what that's doing. I don't know exactly, but it's like you play with those all day. Beautiful. So these giant lamps go in then through the color wheels, then go into this tiny little glass light guide like this. So there'd be a 45-degree mirror in there, so it bounces that along, goes along, comes through here as well. There'd be another, like, splitter. Then they both head off over here into the DLP projector system inside this massive die-cast block here. It's really something else. And I assume that all these gaps in here are for, like, alignment purposes. So these would be aligned by someone in the production. So I presume this would be assembled by grey-bearded nude virgins at the factory with their tongue at the right angle to get the exact optical angles required in there. So yeah, I think they've deliberately done like a bit of play in there so that you can fiddle around with that and calibrate it. Someone was thinking when they designed this die-cast alloy case, get my screwdriver through there and take out that screw. Beautiful. There you go. Isn't that beautiful? And the light just pops out there. The combined light from both lamps just pops out there into the DLP projection part of it. And I'm actually having a real hard time trying to get the rest of this apart because it requires really long torque screwdrivers to get right down to the bottom, down in here, to get stuff out. Like I'm able to get just on an angle slightly here, but geez, it's not good. Well, there's a really nice power supply module. That's a keeper. You might be able to use that for something. No expense spared in any of this. It all uses top quality brand parts, but you'd expect this. This thing costs an absolute fortune. It's designed for 24/7 operation, and it's like as top of the line as you can get in these sorts of professional projectors. I'm trying to get this front assembly out. There's 3 long screws in here that feel like, well, they're not that long, but damn, they had Loctite and they were hard to get out, and they feel like it's all spring-loaded together or something, like there was some pressure holding that in. It's some multi-part, well, it's not even the lens, because the lens screws on the outside here, and you can get different lenses for different functions and capabilities, even something about some sort of infrared thing, I don't know. Yeah, there seems to be some springs between these plates here as I loosen this other one. Oh yeah, I can see the spring in there. Front assembly's held on by, like, why would you like spring decouple the front? Anyway, they've gone to that sort of effort. I mean, this thing is just incredible. And by the way, I found out, I found the data sheet for this thing, and the lamps in this, they were actually hot swappable. So you could keep your presentation going while your brightness went to half or whatever, and you could race around and change your lamp in the thing. I mean, you know, it's really designed for, as I said, 24/7 operation and professional operation. There you go. We got the front assembly out. That's just that, that's not a lens, that's just that plastic protection thing. Perhaps they're actually using that to decouple the vibration from the fans in this thing to the lens. That'd be my guess. I don't know. If you've got any other better reason, leave it in the comments down below. But geez, you know, that's it's pretty impressive stuff. This is spared no expense. It's got die-cast alloy for everything. Yeah, unfortunately, we can't see anything down there. It's just like a big black shutter or something in there. Once we get it further apart, we'll find out. But yeah, little big die-cast alloy block, and then this assembly where the lamps went into, this is all die-cast alloy block, once again separate and bolted onto this huge part here. It's just enormous, and there's a big blower fan under there as well. So it's just amazing. And you can see that this motor here actually adjusts this whole front assembly, so you can actually shift it and you can align the calibration of it. So that'd be like a software calibration. You know, you can push the button and you can align it so it matches up on the screen where it actually projects to. Look at how thick the die-cast alloy is on this mongrel. Perfect example of where a spinny top driver comes in handy. Look at that. Beautiful. So it looks like this whole assembly is going to hinge once the screws come out. No, it's going to get caught, but going to need a little bit more leverage on that, I think. Oh yeah, there we go. And none of that self-tapper rubbish either. Got giant big metal inserts here, metal threaded insert, like giant posts that actually go in there holding down that whole assembly. Wow, this is built like a brick dunny. Okay, I'm hoping this lifts out now. That's the plan. Holder in there. Well, there we go. Whoa, look at that. There's a couple of things I need to get apart. I'll get back to you. Just found like these custom metal bars here that went down. Like, what? How much do they cost? And there's the base of it, all nickel screening. Look at that, beautiful. And there's your big blower down in the bottom. Geez, that could suck a golf ball through 40-foot of garden hose, I reckon. That's what she said. There's the front panel lens release mechanism. I've gone to a lot of effort for that. And they somehow determined that the nickel screening on the case wasn't enough, so they did this metal shield at the base of the main processing PCB. What the? Anyway, what's this over here? Well, it turns out that's an LM92 I2C digital temperature sensor, national jobby. Yeah, it's mounted over there, so they were trying to get, I guess, the air's coming in here, so I assume that's the ambient air temperature sensor. And that's the thing, like, if you're penny pinching your design process, there's no way you design that in with this custom cable loom, this custom board, and the, you know, your extra moldings in there and stuff. Well, that doesn't cost any extra in the scheme of things, but, you know, it's all got to be designed in and thought about and everything else. If you're doing it, like, on the cheap, you just whack it on the edge of the board here, because the board, like, comes out to here or something. So you just whack it on the edge there and, she'll be right, mate. No workers. And check out the design touches here. This has been a huge design team effort. How? this power wiring, right, which, snakes its way through here and all this. Look at this, right? They've gone to the effort to mold in posts into this fan assembly here, and then mold in built-in like supports where you can sit in the ferrite beads there, where they know how many turns they're going to have, and they can wrap it in there, and they've designed it all to for that wiring. It's like usually you don't do that. You don't go to that sort of design effort, like integration design effort. You would just go, oh, well, I'll just tape it down, she'll be right. Just, wow. Anyway, it looks like this entire fan assembly is just for the lamps, really. So that giant heatsink we saw on the back of the assembly, we'll see in a minute. Again, yeah, that was for the DLP projection part of it. This is for the, 2, 800 watt lamps or something. Oh, that fan's not even screwed in. It's got rubber baby buggy bumpers holding that in. Sunon, once again, they've used Sunon for absolutely everything. That's going straight to my miscellaneous fan bin. And there you have it. There's the entire DLP assembly. Isn't she an absolute beaut? And once again, lamps go in here, all this big die cast, that light combiner that we actually saw there. And as I said, these are hot swappable lamps. You saw the interconnect switches that would turn these off the instant you opened that door. So this thing would be almost guaranteed to keep running. Like if one of your fans blow, okay, you get half the output, but somebody can race in there and change it while the presentation is still going. And then we've got the whole shift assembly, the whole lens shifting there. There's another motor down there, so maybe it does shift in that direction as well. Yeah, that's almost certain. So there you go. Oh, look at that. And they got limit switches on there. Check it out. So, the software detects when it gets to end of travel there and just cuts out. That motor goes in the Y direction like that. So X and Y alignment of your lens. And check out these custom screws and grommets in there. Look at that. Beautiful. Like, you wouldn't get that off the shelf, would you? So that's an interesting interface. Look at that. There'd be a gear reduction mechanism in there, and they've just got this little blade that goes into here, which then that just turns that shaft in there. That's kind of groovy. Why not? And this is all metal, none of that plastic rubbish. Got to remember, this is just for the lens shift, okay? Which you only do once, usually, or, not very often. We've got a Japanese motor here, no wuckers. That goes straight into my motor bin. And let's have a look. Look at this. Look at the effort they've gone to there. Wow. I don't know what reduction that is, but that's just insane to go to that sort of effort just to shift the y-axis of the lens assembly. Wow. But the x-axis is near identical, except it's got the shaft coming right out with the same interface, which then goes over to here. And then you can see the those metal rods that we had there. They've got 2 of those, one either side, and that's what the y-axis part of the head assembly actually rests on, with what looks like bearings in there as well to get a nice smooth ride. Unbelievable. Oh, gotta wonder what that's doing down in there. My guess would be some sort of light level sensor or something. It's sensing what light is internal inside the whole assembly. That'd be my guess. So can the mechanical engineers out there please rate this on a scale of over-engineering? Got to remember, this is a projector, right? It's all it does is it projects a computer screen onto, granted, it's probably one of the world's best. Let me know also in the comments down below if you know of a better one. And by the way, look, they've molded in that screwdriver. They thought about that. That is actually a screwdriver slot to stick your screwdriver through. And, it's just, yeah. But, oh, actually, that's surprisingly light. I think that might be a magnesium alloy. So, I don't know, I could get a torch to it and find out. So I was just surprised by the lightness of that. So I think that's a magnesium alloy. And also, mechanical tooling experts, rate the complexity of that mold piece, please. Once again, rate complexity out of 10 down in the comments down below. Like, that is one piece. And it's like it's got things in the way down, you know, I know a little bit about molding maybe. It's like, oh, is that like do they do it like in two halves and then put it and then stick it together somehow? I'm not sure, but yeah, that's just one impressive bit of kit, isn't it? Just to hold the lamps and to do the light combination as well, but jeez. And hello, I spy another shaft in there. I spy another adjustable thing. That looks like an adjustable lens here, which is, this is the incoming light from the lamps. So let's get this structure apart. And, oh, wait, look at that. There's a mirror on the bottom. Wow, I did not expect, I did not expect a mirror to be in, like, on the back of that alloy housing. And they've got this black, obviously for optical reasons. So the light comes through here like this. I think this is adjustable, or something's adjustable in there. Oh, no, it's this. That's adjustable. Not sure what's going on. So this black part is up the far end. So I guess they don't want any reflections. When the light comes in, if there is any stray light, they don't want light actually reflecting off this end and coming back and spoiling the image. So that's a nice touch. So what it looks like is the light comes in here like this, bounces off that mirror there, which then bounces off that mirror you saw in the top of here, like this, and then that so it comes in, bounces off that, bounces off this, and then bounces into the DLP assembly down in here. I'm not sure what this is doing here. Once again, yeah, that's actually what I thought was a sensor, a light sensor before on the outside. It was obviously a motor of some description, because this looks like a little motor, and you saw that shaft on there before. So this is somehow adjusting this, which is some sort of filter, because it's not a mirror. So it's some sort of optical filter, and it's just, I don't see how it's quite in the light. Oh, does it swing out or something? No, I can't see how that actually works at the moment. I'm going to have to think about it for a bit, but actually, I don't believe that's a motor. I believe it's a solenoid. So this somehow flips or something. It does something. And as I showed, there's another one on the bottom down here as well. So there's another something inside there that flips. I'm guessing, that would be, there you go. That would be this protective shutter down here. And there you have it. I did flip that out of the way. Could do that manually, and we can see our DLP sensor down in there. Whoa. Gonna have to get that under the microscope. And if you look through this lens assembly here, then you can see the sensor in there, and that sensor is showing my hand over here, like that. So the optics in this thing are just, like, they're just absolutely marvelous. There's lots of precision that goes into these optics. It's just absolutely incredible. All right, let's see what's behind the heatsink. Well, I know what's behind the heatsink. It's the, oh, there we go. Big heatsink on the back of that. Nice. And we've been mooned. There's the back of our DLP, well, projector I'll call it, but really it's just a bunch of mirrors, a bunch of software-controlled mirrors that reflect the light, really. They're actually micro mirrors, and yeah, that's they've got a cutout in the PCB there, and there's the part number for those playing along at home. So don't know who makes that, but I'm sure it's worth a pretty penny. It's probably that DLP chip is probably worth more than, you know, entire low cost, you know, consumer projectors cost in their own right. I mean, it's, yeah, if anyone has a price, put it in the comments. Wow, check it out. That's actually a pin grid array, which is mounted in the, like in the actual heatsink itself, and then it just uses a big contact array on the PCB here to actually connect to it. So yeah, that's pretty groovy, huh? So there's the back of the board, and here's the front of the board, and all that heatsink and blower assembly comes off there. Aha, there's our DLP engine, and there's our main board. I don't know what that bottom device is because it's got a heatsink glued onto it, but there's our DLP driver chip, and DLP, a Texas Instruments technology. There you go. If I can pull up the data sheet for that one, I will, and I'll link it in down below, because that's the heart of the driving thing for this. So that's TI, is it? It doesn't have the usual TI logo, but a Texas Instruments technology. So I got to assume it's associated with TI in some aspect. Yeah. And I love this. It looks like in the field of DLP projection technology, you don't have any of this pin 1 rubbish. You have the angle of it, well, the incident light angle, I guess. Okay. I think I actually rubbed some of the number off there with my isopropyl wipe. Oops. Anyway, yeah, this just lists out of here, has its own complete assembly. I haven't looked at the bottom yet. I'm going to get this under the microscope, and whoa, there it is. Oh, look at that. Oh, gold plated. Oh, beautiful. But apart from that, what do we got here? It looks like, yeah, that's a big hunk and chunk of glass under there, I think. Just the lenses for these things, especially the actual panoramic projection lens itself, probably costs 10 times more than what a low-cost consumer projector actually costs. Looks like that hunk and chunk of glass there is actually the prism in there like that, and it looks like then there's another prism on the top side of that there. So yeah, I don't know why they're using 2 there. If anyone knows, leave it in the comments. Optical experts. Oh, this is just so cool. I love it already. I haven't even zoomed in, and I just love the colors on here. Oh my goodness. Look at the colors reflecting. Like, it looks like colorful wires or something, like rainbow wires or something. But that's reflecting from my lens. Like, is that the internal light? Yeah. No, that's the internal light, my Tagano microscope light doing that. Let's zoom in. Remember, the Tagano has 40 times, effective 40 times optical zoom. But look at, that bloody flicker thing again. I thought I fixed that by choosing the correct input. Obviously not, damn it. Oh no, this is just unusable now. I'm going to have to swap inputs, hang on. Wow, that's the worst flicker I've ever seen. I've done a video on those flicker, what actually causes this flicker problem. It's the input chip used on my ATEM, my Blackmagic ATEM. Oh wow, sorry, epilepsy warning. There we go, swapped inputs and fixed that. I thought it's a problem with the inputs 1 and 2 on my Blackmagic ATEM Mini Extreme ISO switcher. It's just the TI, is it TI chipset used? Anyway, I've got videos on that. Go watch it. All right, bit of noise, don't have enough light here. So anyway, there's the bottom of that. So if anyone knows what that is, yeah, it looks like I think the number was better before than but I rubbed it off with my isopropyl wipe, I think. Anyway, if I can find info, or you've got any info on who makes that DLP sensor, then a sensor. It's not a sensor. It's a. These are just micro mirrors, but I'm not seeing them. Now, I'm pretty sure I've looked at micro mirrors in another video, and we could physically see them, but I'm not seeing them here. Maybe it's just got a protective layer on there, which means that we can't adequately see them? I don't know, but usually you can actually see the physical micro mirrors in there. Like they're little, like, I don't know, hexagonal shaped mirrors, like each individual mirror. I'm going to have to get it under a better microscope. Going to go for the Olympus jobby. Bloody technical problems. Look at it. There's something wrong with my HDMI cable, I think. The colors aren't coming out properly. Sometimes it does, sometimes it doesn't, but we're getting there. We've got that under the Olympus microscope, and we can start to see the individual pixels. Now, a bit higher magnification. We have to readjust our focus. Whoa, oh, can't quite get that. It's not quite balanced in terms of flatness on there, but anyway, we can see, yeah, the individual little mirrors on there. Wow, it's got a lot of mirrors. What is it? I think it's, 2180 by 1080. I think it's got like 2000 and something mirrors by 1080 mirrors. But yeah, we can see the individual mirrors. So let's go in. That's 20 times. So that's 200 times magnification. Let's go in even closer. There you go. That is the best zoom I've got here. And we can see the individual mirrors. So each one of those mirrors can actually has its own little tilt adjustment on it. And yeah, we can just, like, it's just unbelievable. I really have to tweak the stage on this thing. It's Loosey-goosey. Yeah, anyway, I'm not sure why the ones on the edge are like that. I'm not sure if they're like surplus ones or like, you know, excess ones. Why they're flipped and everything else is like perfectly, or they're flipped in the last position it was flipped on. I don't know, but I'll see if I can get some light at different angles. I'll switch off the internal light. No, it's not really going to do the business. Each one of those is a micro. I'm sure I've shown it better in another video. I'll have to find it. I did a teardown of something that had micro mirrors in it, and I'm sure I did. I've made too many videos. So we can adjust that, and you can kind of see the 3D nature of that, I guess, for want of a better word. Because these mirrors, they do actually tilt, and they can reflect or reject the light at the incident angle, hence that incident angle on the PCB. You know, you've got light coming in at a certain angle, and all you've got to do is slightly adjust the micro mirror to turn your pixels off and on. It's just insane technology. It's just insane. But yeah, everyone's like using solid state these days, aren't they? No one's. Does anyone? Is DLP still a thing? Like, it was a thing like in the 2000s and stuff. It was all the rage, and you can get good and bad ones. This is obviously absolute top of the line. Interestingly, the bottom edge down there doesn't have like a whole strip that's like just randomly like tilted. There's the bottom corner down like that. So yeah, I'm not sure why the top has a whole strip or something. But as I said, that might have been like the previous state. Can actually slide in a different light filter like that. I think I can see an outline of some text. Is that an outline of text there? Or am I just imagining, is that my brain imagining things? Check it out. I can adjust the aperture for the light like that. You can see the individual pivot point. You can see the individual pivot point on each of those mirrors. Isn't that cool? Huh? That's great. Look at that. So yeah, I'd say that they've had that. That's just a previous state. That's great. So anyway, thank you very much, Morton, for sending this in at great expense from overseas, because it does cost a lot to ship these things, you know. Thank you very much to everyone who sends something into the mailbag. This was absolutely fascinating, of top-notch, no expense spared engineering for probably one of the top-of-the-line DLP projectors that's designed for like 24/7 operation, hot swappable things, lens swaps for different panoramic modes and all sorts of different things. As I said, even like some sort of infrared thing or something. I don't, like, it's insane. The engineering that's gone into this thing for this professional market. Please leave it in the comments down below if you've ever used one of these from this company, and like how much were these things worth? They've got to be like at least an order of magnitude more expensive than just your regular consumer DLP projector, and they were pretty pricey back in the day, weren't they? I don't think anyone does DLPs anymore, but anyway, leave it in the comments. That is absolutely top-notch engineering. Fascinating teardown. Thank you very much, Morton. And if you enjoyed that, please give it a big thumbs up. And as always, discuss down below. Catch you next time.